This will be the first video of another three-part series for solving systems, but this time we're going to focus on elimination. So up until today, or up until this video, there's basically only been two ways we can solve a system: by graphing and by substitution. And I already did the three videos on substitution. Now we're going to do elimination. So for most of you, elimination is going to be the shortcut and you're going to love it. So first step to elimination is we basically are going to stack our equations, treat them like decimals in a way. We're going to stack them vertically and add them vertically. And what will happen is that certain terms will cancel out, which will enable us to quickly solve for one of the variables and then substitute the variable back in to find the value of the other variable. So when it comes to the first couple of steps to elimination, it's different than substitution, but after we do the first two steps, the remaining process that we follow is exactly like substitution. Okay, so first off, here are our two equations. We have equation 1 and equation 2. Now, to solve a system by elimination, what you're basically looking for are certain variables that are inverses of each other. So, for example, if you look at the y terms, this is a 1y and a 2y. These are definitely not inverses because remember, inverses cancel each other out. If you recall, we always use inverse operations to solve equations, okay, because they cancel each other out. But if you notice right here, the x terms are exactly inverses. So that is our sweet spot that we're going to start with. So the first step to solving a system by elimination is to rewrite your system stacked vertically. So here is equation 1. Y plus 3x equals negative 2, and directly below it is 2y. Now, it's important to make sure that you stack your systems correctly. And what that means is you have x terms over x terms and y terms over y terms and constants over constants. It's just like adding decimals. Remember, to add decimals, we line up the decimals. We put in any zeros if we need to as placeholders, but everything must line up. So, now, if we go ahead and look at this, because these are already inverses, all I'm going to do now is put a little plus sign here and add straight down vertically. So I can think of this as 1y plus 2y. So together right here I have 3y. Well, 3x plus a negative 3x cancels each other out to 0. And so this becomes 0. And negative 2 plus positive 14 is positive 12. So now if you look at our equation, we have 3y equal to 12. Well, we can solve that easily by dividing by 3. Y equals 4. So we eliminated the x term first so we can solve for y. Now this is the spot right here is what I was referring to earlier when I said we're going to be using the same steps as substitution. Once I know y, how do I find x? I just put it right back into one of my original equations to solve for x. So let's go ahead and use equation 1. Remember, it doesn't matter which one. I picked 1 because y had a coefficient of 1. So let's go ahead and do this over here. So we have y plus 3x equals negative 2. So this is equation 1. I'm now going to substitute this in to solve for x. Again, use my inverse operation here. Divide by 3, another inverse operation. X equals negative 2. So what do we do now at this point? We're going to check it. So let's test it in equation number 2. So I said x is negative 2 and y was 4. So 2 times 4 is 8, a negative 3 times a negative 2 is a positive 6, and 8 plus 6 is 14. Let's test the other one real quick. Again, y was 4, 3 was negative 2, 4, this is going to be negative 6, 4 minus 6 is negative 2. So our solution does work, and our solution was negative 2, 4. Remember to write your answer as an ordered pair.